Welcome to the Resairchia YouTube channel. In this video I will show you how to use Modia together with the XFOIL package available in Julia. This way you can build your own aerodynamics simulator. The XFOIL package is well documented in the Julia documentation, on GitHub and the MIT website. XFOIL is a program for the design and analysis of airfoils. In the XFOIL package documentation, you can find examples showing how to use the XFOIL package. I will start with this one. Notice that you need the airfoil data points in your current directory. These are the data points that I have found for the airfoil that we will use. I will leave the data points in the description and the commands needed to check your current directory, so you can have the file in the proper folder. I will simply copy paste their example. You can see that we obtain a list of very important values depending on the angle of attack. In this video we will only use the lift coefficient. I will start by writing my own function calling XFOIL and check that it works. Great, so we have a working function to obtain the lift coefficient depending on the angle of attack and for a certain value of the Reynolds number and the Mach number. The Reynolds and Mach numbers are very important in aerodynamics. You can search their meaning if you don't know what they are used for. Now we need to use our function in Modia. I have written a very simple model that changes the angle of attack by 1 degree per second starting from 0. We will store the computed lift coefficient values in a variable called computed CL. To access this variable, I will need to use a few new commands that we have not seen before in the tutorials. The model instantiates correctly, so we can simulate. I will start by plotting the changes of the angle of attack depending on the time. Perfect. There is nothing important to see here, but I like doing this to check that everything went correctly. To access the computed CL variable, we need to import the Modia result. We use getPlotSignal to access our computed CL variable. We can see that the values of time and the values of the computed CL are stored here. Now we have our results in a variable called results obtained, which is easier to access. And now we can plot the results using different combinations. This first plot shows the values of the angle of attack depending on the time. This plot shows the values of the angle of attack depending on the time combined with the values of the computed CL depending on the time. And now I will plot the values of the computed CL depending on the angle of attack. You can see that the values of the lift coefficient are not a completely straight line, since XFOIL needs to iterate to obtain the solution, and predicting aerodynamic values is always a very complex matter. To visualize the airfoil, I'm using Octave. You can simply copy-paste the data points and then plot the points rescaling the y-axis. I will leave in the description some very good references related to panel methods for computing aerodynamic values of airfoils and Mark Drella's book, which is very good if you want to learn more about theoretical aerodynamics. Thank you so much for watching and see you in future videos.